In the future of space science, we see space no longer being the sole domain of very large organizations. It's going to be in the hands of the people.
A number of students here at the University of Alberta who were passionate about space came together. The objective was to design a small satellite called a CubeSat.
Who would have thought that you could access space as an undergraduate student? As soon as I heard of that, how can you say no to that opportunity?
So much anticipation and so much build-up. The actual moment of the rocket launching and going off into space was just like everything stopped.
To know on board in that cargo is a space vehicle that you've built, sitting on the pad and then watching it blast off into space.
This is a long 4 or 5 year journey that we'd all, poured our blood, sweat and tears into. For it to be in space was nothing short of amazing. It was a surreal moment.
AlbertaSat started with a group of enthusiastic students who basically wanted to go to space. They approached some of the space experts here at the University of Alberta, and we got together an interdisciplinary team that set ourselves the goal, hey, let's build a spacecraft, let's test it, integrate it, and let's go fly it.
The team is composed mainly of undergraduates, engineering students, science students, and we've had students from the faculties of business, marketing, finance, education. If you're interested in space, we can find something applicable for the skill set that you have.
An opportunity came up to participate in a large mission with other CUBE satellite teams from around the world. The mission was called QB50. We went through the process of working to design and build the experimental Alberta #1 satellite to focus on research goals for the University of Alberta.
Exalta 1 is a 3-unit CubeSat, so it's 10 by 10 by 30 centimeters. Despite being that small, it packs a large scientific punch. And its purpose is to study space weather. So basically how do charged particles from the sun and other sources within the universe interact with our magnetic field and atmosphere.
If there's a strong disturbance in space weather, a big explosion from the sun comes and starts a big storm, radiation can penetrate into satellite components, can damage them or potentially knock them out.
We received lots of support and funding from the university, but we also ran a crowdfunding campaign. It just showed how much the community and just generally everybody loves space. They got to be a part of the mission to launch Alberta's first satellite into space.
We knew the scientific payloads we wanted to put on there. Then it was a matter of figuring out, okay, how do we design a satellite bus system that accommodates all this? Then we purchased or built all of our hardware and brought it all together in the clean room, started testing it, and then it was ready to be delivered.
The experience of seeing it first launch into space aboard the rocket and going to Florida and watching it, that was an amazing moment.
We were at a gantry 3 kilometers away, so it was as close as you can get to where the rocket was launching from. So we had the best seats in the house.
Then the deployment from the International Space Station, and everybody was just all smiles and cheering. We actually were able to go outside and watch as the International Space Station flew over, and we knew that our satellite was right next to it.
Exalta 1 comes over the horizon, we point our ground station antenna at it, and then we establish a link of communication. And then we start uploading commands, downloading data, whatever is the flight schedule for that day, and we have assessed as the most important thing to do on that pass. Flying the satellite, it's doing very well. We've done a great job, but we got a lot of things wrong. And every time my hands are on the keyboard to fly that thing, I'm incredibly careful because I know it's everybody's baby. We're like a large family here.
In a project like this, there's so many pieces that have to fit together that there's lots and lots of opportunity for student leadership and student development. And the students have learned much more by having to reach a solution to their problems than they would just somebody trying to explain to them, how do you design a particular system?
Normally you'd think if you were getting a hands-on kind of training, it would be with something more domestic or something smaller scale, but it absolutely can apply to things on a cosmic scale like this.
Because I flew the satellite over the summer, that's instilled more confidence in me. When I'm in the middle of a test, I can say, this question is hard, but I fly a satellite, so I can figure this question out.
We started up a spin-out company called Promethean Labs, focused on doing remote sensing, so using specialized camera systems to observe crops. We can dream big and succeed in those dreams because we've done it with a satellite.
Exalta 1 is going to last about 1.5 to 2 years. Following Exalta 1 is Exalta 2, and Exalta 2 is also a 3-unit CUBE satellite. The main payload on Exalta 2 is a multispectral imager. The data provided in those pictures will be given to wildfire scientists, and they can identify where wildfires are most likely to start, where they're actively burning, and they can also look at the post-burn scarring effects that wildfire leaves on the land. The other aspect of it is to establish an open source CubeSat platform.
One of the big purposes of AlbertaSat is this idea of creating opportunities of opening access to space and space science. And the best way to do that is to share the ideas.
We go to mostly elementary schools, but right now we have sessions for kindergarten to grade 9, and we're currently developing high school sessions to reach kids and introduce them to the idea of space science.
All the data that we collect, whether it's from the satellite or information about the systems that we design here, is available for the scientific community to use.
If there's an open source push within the CubeSat community, what you'll see is many more CubeSats being sent to space. So that means that a team can send not just one, but many CubeSats, creating a constellation. When we go to do the next one, we build however many cube satellites per constellation, put them up there, and then we have constant monitoring of forest fires across the globe.
If we open the research community up with an open source approach to satellite technology, and then if we work together as a global community, I think then we will really be in a position to make very great strides forward.
Because we have all different kinds of people coming up with ideas of ways that we can use space to our benefit, we can really harness space to benefit the globe.